Functions in Go are first-class values. They can be assigned to variables, passed as arguments, returned from other functions, and stored in data structures. This episode covers Go's function system from basics to closures, including the idiomatic multi-return pattern that underpins all of Go's error handling. The anatomy of a Go function: func keyword, name, parameter list with types, return type, body. Simple and consistent. When consecutive parameters share the same type, you can write the type once. Functions with no return type simply omit it. Functions with no parameters use empty parens. Both are common. One important rule: every declared variable in Go must be used, and every imported package must be used. But unused function parameters are fine. You'll sometimes see as a parameter name when the signature is required but the value isn't needed. This is one of Go's most powerful features, and it's at the heart of how the language handles errors. A function can return multiple values by listing the types in parentheses. 2 return types: a result and an error. 2 return statements: 1 for the failure path, 1 for success. This is the canonical Go pattern: result first, error last. You'll see it tens of thousands of times in the standard library. Calling it, the compiler forces you to handle both return values. You can't just call divide 10, 2, and ignore the returns. That's a compile error. You must either use each value or explicitly discard it with. This explicitness is the feature. In languages that use exceptions, errors can silently propagate up the call stack without the programmer doing anything. In Go, errors are values, and the compiler ensures you at least acknowledge them. Ignoring them requires deliberate intent. Multiple return values aren't limited to error handling. Strconv. Atwa returns, int, error. OS. Open returns, file, error. Net. Dial returns, con, error. The pattern is universal. Go lets you name the return values in the signature, which declares them as variables available throughout the function body. Named returns serve 2 purposes. First, they document the return values. Reading min, max, sum int tells you exactly what the function computes. Second, they enable the naked return statement, which simply returns the current values of all named return variables. Use named returns selectively. For short functions with descriptive names, they improve readability. For longer functions, explicit return min, max, sum is clearer because you can see exactly what's being returned at each return point. Named returns become particularly useful with defer, because deferred functions can modify named return values, allowing cleanup code to, for example, wrap errors with additional context. We'll see this in episode 11 when we cover defer. A variadic function accepts any number of arguments of a given type using before the type. Inside the function, numbers is a regular int slice. Outside, you call it with any number of arguments. You've already been using variadic functions fmt. Println and fmt. Printf are variadic. Their signatures are func println a, any, and func printf, format string, a, any. When you already have a slice and want to pass it to a variadic function, use the spread operator. After the slice, the variadic parameter must always be last. You can mix regular parameters and variadic. In Go, functions are values. You can assign them to variables, store them in maps, pass them to other functions, and return them. Defining a function type gives a name to a particular signature, and passing functions as parameters enables the strategy pattern. You can also define anonymous functions inline without giving them a name, useful for short transformations you only need once. Apply is a higher-order function. It takes a function as a parameter and uses it to transform each element. This pattern, map, filter, reduce, is central to functional programming and works naturally in Go. A closure is a function that captures variables from its surrounding scope. When a function is returned from another function, it can carry those captured variables with it. They remain alive as long as the closure exists. MakeCounter creates a local variable count, then returns a function that increments and returns it. Once makeCounter returns, you can't access count directly, but the closure can. Each call to C modifies the same captured count. The variable persists because the closure holds a reference to it. Create two separate counters and they're independent. Each has its own captured count. The function factory pattern takes this further. Each call to multiplier creates a new closure with its own captured factor. Double and triple are specialized functions manufactured from the same template. This is the basis of many Go patterns, middleware in web servers, option functions, decorators, and more. Functions are straightforward to declare. Func name, params, return type, group same type parameters. Multiple return values are idiomatic, result then error always. Named returns document the signature and enable naked returns. Use them in short functions, be explicit in longer ones. Variadic functions use type, receive a slice internally, spread a slice with slice. To pass it. Functions are first-class values. Define function types for reusable signatures. Pass functions as parameters for the strategy pattern. Closures capture variables from their enclosing scope. Use them for stateful functions, function factories, and middleware patterns. Episode 10 covers Go's data structures in depth. Arrays, slices, maps, and how they work under the hood. See you there.